You've heard a lot in the media, read a lot about the importance critical national infrastructure and the role that 5G plays in that. Can you talk a little bit about the risks to critical national infrastructure as you're seeing them today, and what are some of the things that we should be concerned about?
Well, 5G is really the underpinning the technology is a goal to really provide ubiquitous connectivity for critical infrastructure. 5G has designed into it objectives to provide seamless connectivity and really bring AI to the edge to advance our critical infrastructure. The challenge, of course, though, is as we connect critical infrastructure, often which is legacy equipment supporting very important missions, we end up with a situation where you've got things that are connected to the internet in ways that perhaps were unanticipated when the equipment was designed. And so there's a lot of opportunity for the critical infrastructure sector for leveraging 5G, where you're able to bring advanced analytics to systems that really can take advantage of it. But we also have to be thoughtful in how we design these networks so that they meet the security objectives that are fundamental to ensuring security for U.S. critical infrastructure.
So when you're talking about security, it's a great topic, multifaceted. And a big buzzword today is zero trust architecture, or zero trust for short. When you think about 5G networks, how are people thinking about doing zero trust for this ubiquitous connectivity model that you're talking about?
Yeah, so zero trust is a pretty broad term that encompasses a variety of different technologies. And I think the definition is really continuing to evolve as we learn more and begin to implement it in new areas. I'd say one important facet of zero trust is knowing who the users are on your network, knowing the identity of devices that are connected to it. And that's not always easy, particularly in the field of Internet of Things or IoT. We don't necessarily have a good, unique identifier for many of the devices that are connected to our network. And if we don't know the identity in a secure way of the devices connected to our network, there's no way we can make decisions at a policy level about what services they can access, what networks they can connect to, and it's really hard to build a larger security fabric on top unless we know those identities.
So I love the concept of identity, both identity of people, but of identity of things. So let's talk a little more about identity of things. When you think about doing that, and you were kind of evaluating the marketplace around technologies that could help with authentication, encryption of the endpoint and smart things, as you said before. What are, from a technology perspective, obviously at SecureG, we're really interested in PKI, but what are, maybe some other technologies that are complementary and maybe some of the advantages of PKI from an identity perspective for IoT?
There's lots of ways to authenticate a user or a device. For users, it's often easier to authenticate them with a username and password because it's something they remember. They can type into a keyboard in order to access a system or a network. Devices, on the other hand, don't have the same sort of memory challenges of needing to remember a password or things like that. And so we can actually do a lot better and have much stronger credentials for devices that are connected to the internet. And that's where the role of public key infrastructure comes in, or PKI. You actually can provision these devices with cryptographic keys that will uniquely identify them to the network, and do so in a way that's a lot more secure than a username and password. It also addresses some of the challenges of provisioning of these devices. In the early days of IoT, oftentimes you might have a device that's connected to the network, but it would have a default username and password, which would allow hackers to get in and exploit those devices. Some of the largest botnets ever created have come from poorly provisioned and configured IoT devices, from printers to refrigerators. And so I see the opportunity to really increase the robustness and security of IoT and its connectivity to the internet through the use of public key infrastructure.
So one of the things, at least when I talk to people about public key infrastructure, is, oh yeah, that's a technology. It's 30 years old, and that has its opportunities, and that it's kind of a well-established standard, but also its challenges in that people kind of view it as something that maybe can't keep up with the speed, the latency, other thing, maybe cryptographic algorithms as well, and encryption. Can you talk a little bit about public key evolution and maybe some gaps and where, a little bit to the genesis of kind of early days of secure G and how it was kind of thought of and brought together?
And so public key infrastructure has been around for many, many years. I'd say that when it was first designed, the killer app for PKI was really to secure websites. So if you went to a website, you get that little lock icon in your web browser, and you know that the data going between your browser and the web server was encrypted. And the entire sort of PKI industry grew up to support that killer app, right? Because that's where the money was. But I think with 5G, we've seen a fundamental change. 5G is the first wireless technology that's gone all in on public key infrastructure, not just for authenticating devices, but every single component inside the 5G network is designed to authenticate to every other single component using PKI. And so essentially the shift in wireless standards going all in on PKI necessitates us to rethink PKI at scale, right? PKI was never designed to be, say, cloud native or IoT scale. And I think that as we shift into 5G as the connectivity and IoT as a predominant device connected to our wireless networks, we need to fundamentally rethink the speed and scale at which PKI is designed, which means really revamping the entire way we do key management. And we can really modernize this technology, and that really was the early vision for Secure G.
That's awesome. One of the things that comes to mind when you start talking about encryption, and you talk about the risks to the network, is the risks that quantum computing poses. So while we kind of look on the horizon, and we don't know exactly when that day is going to come, we know that quantum computing is, a lot of effort is being put around quantum computing. Can you talk a little bit about maybe the risks that quantum computing poses and the potential defenses that we could implement to combat that?
Certainly. So under the hood of PKI is public key cryptography. And public key cryptography relies on basically hard math problems. And these math problems we thought were hard until a theoretical quantum computer comes along, in which case they're not hard anymore because the quantum computer is able to solve them in a way that conventional computers cannot. So there's been an effort underway for quite some time to think about a quantum safe cryptography, also known as post-quantum cryptography. And in fact, the NIST, which is the standards body that oversees these cryptographic algorithms, has recently named the encryption algorithms that will be used and standardized for quantum safe applications. So I think now ahead of us is a tremendous uphill. The entire industry needs to come together to figure out how to take these new standards and implement them and deploy them. And as we rethink PKI, I think we have the opportunity to rethink PKI at a time when the underlying cryptographic algorithms are changing as well. So we can address both the quantum challenges in addition to the scale challenges that legacy PKI represents.